I have a lot of sympathy for Theranos, the innovative diagnostics company, and its visionary CEO Elizabeth Holmes. 1 minute loaded, the next minute pilloried. Their and her attempts to reshape healthcare have been overshadowed recently by regulatory issues. This fall from grace has important lessons for us and can be explained by evolutionary science. As usual, let me explain the science bit before I return to the practical lessons for the life science industry. As explained in Andreas Wagner's wonderful book, The Arrival of the Fittest, biological evolution is a game of blind man's buff. Genetic variation results in species stumbling through a multi-dimensional evolutionary space. Each mutation is a random step towards no particular goal. Many variations can occur and accumulate with no discernible impact on the biological viability of the species. Some genomes get tantalizingly close to making a huge difference in evolutionary fitness, only to take the next random step in the opposite direction. The point of Wagner's explanation is that many changes are needed to make a positive difference, whilst only 1 or 2 are needed for evolutionary progress to fail. My own academic research applies the concepts of evolutionary science to the life science industry. Just like a biological system, our industry is a complex adaptive system. Firms are analogous to organisms. They have their own DNA in the form of organisation routines, and there are groups of organisations that share the same DNA, which we call business models. These are directly analogous to species, and they evolve by the mutation of their routines. Looking back to Wagner's ideas about wandering through multi-dimensional evolutionary space, the parallels with industry evolution are strong and informative. A firm will vary or mutate its routines, deliberately or otherwise. These variations accumulate, and once enough changes have occurred, the organisation will develop a new trait, such as an organisational capability. These variations accumulate, and once enough changes have occurred, the organisation will develop a new trait, such as an organisational capability, that it did not have before and which increases its evolutionary fitness. Equally, it may mutate many routines and get teasingly close to developing a new capability, but fall just short of that evolutionary step. The only significant difference in theory is that whilst biological mutation of genes is random and unguided, the mutation of organisational routines is supposed to be deliberate and guided by the careful ruminations of highly intelligent executives. I say in theory because there's been some very interesting empirical work that suggests that practice is different. Hannah Marshall and others have measured and compared the extinction rates of firms and biological species. These researchers find that intelligent mutations of firms and random mutation in biology result in pretty much the same outcome. It is, to quote Marshall, as if managers acted at random. So what does this mean in practice? Well, a CEO trying to evolve a new innovative business model is, in effect, trying to accelerate evolution by directing the mutation of his or her firm's DNA. Its routinome, as it were. They have no option. It has to be done to get to the market first and better. But as Wagner's work tells us, it's easy to get it wrong. In particular, it's easy to make a lot of successful mutations and get most of the way to a fabulous new model, only to find that a tiny number of key mutations either weren't done or went wrong. Looking from the outside, this seems to be Elizabeth Holmes' problem at Theranos. Great technological and commercial capabilities, but something went wrong in that part of Theranos' routinome that expresses the genes for regulatory capabilities. From what I can see, Ms. Holmes is a seriously bright young woman, and my bet is that she'll fix the problem. But the fact that such an innovative firm can stumble as it explores its evolutionary space is evidence of how hard this is. And there is hope for other firms. What we know about the routinomes of different life science business models is improving all the time. That's what I spend my life researching. And the takeaway from this? Well, if you're trying to design a new business model or to evolve an old one, think through the traits it needs and how that translates into its routinome. That puts you in a position to do your own equivalent of genetic engineering within the firm. Without that knowledge, you really are playing blind man's buff. With it, you're not guaranteed to get there, but you are less likely to take a fall like Theranos. And in developing a new business model, just as in developing a new product, anyone who fails because they haven't made use of the latest research in the field isn't just unlucky, they're naive.